Okay, so we're going to try this again, a second video. Don't worry about watching the first one because we covered it in class. But this video will talk about the graphing of data, which we worked on in class today with the iPads. So we're going to graph the relationship between independent and dependent variables. And if you remember, the independent variable is the one that we will change. The dependent variable is the one that will change because of the other variable. And then we're also going to learn how to interpret graphs and recognize the common relationships in graphs. We're just going to cover a little bit of this. So identifying variables. A variable is any factor that might affect the behavior of an experimental setup. Those are the things that we change. They vary. It's a key ingredient when it comes to plotting the data on the graph. The independent is the factor that is changed, or the one we manipulate during the experiment, the one we change. The dependent is also going to change, but it will change because of the independent. So it depends on the independent variable. Here is a graph of, or here is some data that has been graphed. We have the mass and then the length, and we did something similar to this in class. And you see the length is over here and the mass is down here. So we have mass and length. And we're not going to watch the movie. I don't think the movie comes on. I'm just going to try it and see. Okay, it did not come up, so we'll skip that. So we're going to talk about linear relationships, and that's what we worked on yesterday. Linear, meaning a line, is where you have a scatter plot of data, and it may take different shapes, suggesting different relationships. But we plotted two sets of data on Friday, and we got a linear relationship, and then we were able to plot another set of data and find the relationship it was to mass versus the area. So linear relationships. Here we have our straight line. We have the rise and then the run. Rise over run gives you the slope, if you remember from math class, the slope of your equation there. So we're going to work more with that, and we'll be figuring out what is found under the slope of an equation. But I think you've all had that in a math class at some time. So the slope of a line is equal to the rise divided by the run, and can be expressed as the change in y divided by the change in x. Y gets smaller as x gets larger, then the change in y divided by the change in x is negative, and then the line slopes downward. The y-intercept, which is the letter b, if you remember your equations, and we'll work with this again on Monday, is the point at which the line crosses the y-axis. And it is the y value when the value of x is 0. Nonlinear relationships. When the graph is not a straight line, it means that the relationship between the dependent and the independent variable are not linear. There are many types of nonlinear relationships. Two of the most common are your quadratic and your inverse relationships. So your quadratic equations, if you remember from math. So the graph shown in the figure is a quadratic relationship. One variable depends on the square of another, and the quadratic relationship can be expressed by the following equation. Y equals ax squared plus bx plus c. We do use this a couple times in later chapters, so be aware to keep that in mind. Nonlinear relationships, when we have the inverse, then you get the hyperbola, and that is what that graph looks like. So you see that the current and the resistance of electricity, when we're talking about electricity, are inversely related. And that is shown by this equation, y equals a divided by x. So we have, the exponential growth and decay used to study radioactivity. So there's different ways, the sinusoids, the model cyclical phenomenon, and so there's other ones that we will use. Combinations of different mathematical models represent even more complex phenomena. So predicting. We can use our graphs to predict values that are not measured directly, and that's what you did in class with the wire and the triangle. You were predicting something that you weren't going to measure, and then we can actually go back and measure those and see if our predictions are correct. So that'll end this this lesson for this weekend. Okay? Have a good weekend. Bye. I'm just letting this record, and I'm going to go through, but I'm going to let you read. So you pause on each question as you go. And then at the end, you'll go to the spreadsheet, and you'll write down a little summary of how you did on the quiz. There's only 3 questions. And I'm going to click through them fast, but you pause them so you can read them, and then the answer is on the second one. Okay, that's the end. Just make sure you pause on the questions and then try them, and then go back and give me just a little summary of how you did on the quiz and any questions you have about the chapter.